These two equations may have one unique solution, no solution, or infinitely many solutions. We'll try to see under what conditions this happens. Let's take a look at these two equations and try to plot these equations on an xy axis. Let's take the first equation and let's assume that this line is like this. The gradient of this line m1 defines how much it's inclined to the x-axis, and let's say it's inclined to the x-axis at theta 1 and m1 is equal to tan theta 1. Now let's take a look at the second line, y equal to m2x, and let's say m2 is different from m1, which means that the inclination of this line is different from the first line. And I plot it to this line like this. If m1 is different from this, m2 is different from the second line, it will be inclined at an angle theta 2, which will be different from theta 1, and that would mean that these lines are inclined at some different quantum. Now these two lines must connect at some point, at least one point, one and only one point. You just have to extend these lines and they will cut it at some point. It's impossible that these two lines do not intersect at one point. So if m1 is not equal to m2, that means the lines are going to intersect each other, and under that condition we will have one unique solution. Now let's say what happens is m1 is equal to m2. When m1 is equal to m2, which means that this line, which looks like this, is going to be parallel to the first line, and this will typically look like this. This is the second line, and these two lines are parallel. This line has gradient of 1, and this line has a gradient of m2, which is equal to m1. When these two lines are parallel to each other, they are not going to intersect at any point, and under such conditions, if the lines are at a certain distance, and let's say this C1 and C2 are different, which means that their intercepts on the y-axis are different, and therefore these lines are at a certain distance from each other, which means that, let's say under such conditions, C1 is not equal to C2, which means that the lines are not going to intersect anywhere in this plane, and therefore we will have no solution. Now let's try to do these things. I'm going to try to this line, move closer to this line, start coming closer and closer and closer, and at some point of time it's so close that they almost overlap. The second line is overlapping the first line, and when that happens, m1 is equal to m2, and these intercepts will also be equal. And when that happens, these two lines overlap each other, so every single point on this line is a solution to the two equations. And under such conditions, we will have infinite or many solutions. This is an important concept, and it's going to be very useful in your higher grade algebra or linear algebra courses as well. What I'm going to do is, this is one way of graphically understanding it, but you can extend this concept to multivariable, for example x, y, and z. Then instead of a two-dimensional line, you will have three-dimensional and planes, but the concept still remains same. Now, what we will do is we will try to formalize these things when the equations are not in this form, but let's say in the equations are represented something like that: ax plus by is equal to c, and dx plus ey is equal to f. The concept still remains same, and we'll investigate it. So let's say their gradients are different. When will their gradients will be different? The gradient of the first line is minus a divided by b, and the gradient of the second line is minus d by e. And let's say if these are not equal, in that case these equations will have one unique solution. Now this also, if I rearrange the term, it is formally written as, to make it easy to see, if I rearrange the term by removing this minus sign and bringing d here and b over there, we write it as a by d is equal to b by e, which means we just need to compare these equations one upon other, this upon this, and see if these are equal. The idea is still same, and this has, these must be not equal, and then we will have one solution. Now what happens if their gradients are different, which means that this a by d, what happens when a by d is equal to b by e? If that happens, which means that these two quantities are also equal, which means that these two lines are running parallel to each other. When these two lines are parallel to each other, we need to investigate how their gradient looks like. In that case, what the gradient of this line is c upon b, and we are going to compare c upon b with f upon e. And let's say if these are not equal, if these are not equal, means their intercept on the y-axis are unequal, and in that case we have no solution. Now this comparison I can also write as a ratio of c by f. So I bring this f this here and b over here. So I can write c by f, and comparing b by e, this is not equal to this thing. So here is what is happening. You compare a by d with c by b by e, and if this is equal, you compare b by e, this b by e, with c by f. And if this is equal, so I can combine these two conditions, that if a by d is equal to b by e, and this b by e is not equal to c by f, in that case you have no solution. And that brings us to the third condition. What if their gradients are equal, but c by b, their intercept on the y-axis is equal, which means that c by f is equal to b by e. Under that condition, their gradients are equal, which means that the two parallel lines overlap each other, and in that condition we have many solutions. So this is how we write it in a formal way. So I will rewrite this equation in a cleaner form. You compare these three fractions. If a by d is equal to b by e, is not equal to a by b, we have one solution. Story finished. But if a by d and b by e are equal, and you proceed to compare c by f, And if this is not equal, you have no solution, which means that the gradient. And finally, if A by D is equal to B by E, the lines are same gradient and their intercepts are also same, which means that the lines are overlapping, then we have many solutions. I hope it helps it. It's going to be helpful for you whether you are doing a linear equation or taking courses in linear algebra.